Good morning and welcome to today's webinar. My name is Ryan Bowles. I'm the Regional Sales Director for the South, and today I'll be taking you through the Trimble SX10 robotic total station and scanner. So thank you for joining us today. Hopefully you'll find this presentation of interest. There will be time at the end to answer any questions that you may have. So we'll crack straight on. So first off, we'll have a quick look on social media, see what people have been saying about the SX10 and more importantly, I guess, what they've been using it for. Then we'll look at, starting the conversation, how do we get into to scanning and what the best tools are. We'll then go through a number of case studies, looking at different ways in which the SX10 is being employed. And we'll finish off then with a live demonstration. So you can see first off in the bottom right hand corner there's actually a bit of data that was collected by myself when the SX10 was first launched. That was a few scans taken in the City of London. So out and about on social media. Well, the SX10 is being used for lots of weird and wonderful applications, not least starting off with utilities. You can see a couple of companies there posting pictures of what they've been up to with the SX10. On the left hand side we can see some of the real clarity that we can get from the scan data. You can see how well it's actually picking up those cables, and on the right hand side you can see them tracing a pipeline. Now the key thing here in both of these applications is actually the controlling of this data. Whether you're doing pipe runs, cable runs, or whether you're following electric cables through pylons, what's key here is it's going to be over large ranges, a long distance, and therefore control is absolutely critical. And that's one thing that the SX10 really lends itself to, seeing though it's a very capable robotic machine for putting control as well as the scanning elements. And that comes through as well when we're looking at quarries. People are using this a lot of the time in quarries. The SX10 itself has got a range of 600 meters. And so, straight away that opens up quarry work massively. Again, we're talking long ranges, and again, control enables us to put control far out into the quarry, so we're not having to rely on protection or whatever. We can put control out where it's safe. Another area where it's being widely used is deformation surveys. Here, both looking at the cliffs and also down in this pipe. So they were looking for any changes in the pipe. So again, it is being widely used. And remember, the SX10 is a 1 second instrument, so very much at home when we're looking at deformation type surveys. Construction setting out is a biggie. It's a huge one for the SX10. Whether you're actually using it to set out points, or whether you're using it to scan a concrete pad once it's been laid, it's a great tool for working out where your high spots are, where your low spots are. You can actually live in the field create a surface and see that information as soon as you've collected it. One of the other features that we don't really talk much about is the obvious one, the lack of telescope. And this helps a great deal because all of a sudden, we don't need to be able to look through the instrument. We can't look through the instrument, and so that opens us up to be able to place the instrument wherever it suits. So if you've got deep foundations, or you want oversight over a large area, we can now place the instrument up high, and you can see that on the right hand side with these mounts that have been created to enable us to place the instrument in a safe place while still giving us good overview. It's just at home, whether it's for setting out, whether it's for topographical surveys, as a robotic tool, it follows on the same kind of path as the standard S-series robotic, exactly the same access software, although slightly updated, and so any of these kind of applications that really come second to none to the system. And with topographical surveys often come elevations as well. And so you can see here on the left hand side of the screen, we can see where the elevations, you can see the live video screen on the top controller, and down below on the TSE7 you can actually see the point cloud data that's been collected. On the right hand side we also have a look at the T10 tablet, where you can see a full scan of a building. So right through all the different applications, we can see how people are using this tool. So how do we start the conversation? Well, when we're talking about laser scanning, we're talking about remote rapid data capture. Measure all, visit once. This is the very key with scanning, is the ability to take the entire worksite back to the office and do the clever bit back in the office. It allows us to have far greater analysis of the site and tells a bigger picture. We're not gathering individual points anymore. We're gathering the entire scene. And down the bottom, you can see a number of different tools that we have available to us to consider, depending on what task is in hand. So, what do we need to consider? Well, it's the type of work. Measure building surveys, is it floor plans? If all you're doing is full 360 scans, then perhaps the SX10 isn't the right tool for you. But you're doing street scenes, elevations, stockpiles, quarries, utilities, topographical work, all these applications, suit the SX10 down to the ground. And what really pulls the SX10 apart from the rest is the ability to be able to very quickly specify what data you actually want to capture. So once you've looked at the type of work that we can do with it, then we need to work out collection versus processing. How much data do you need to collect, and what actually is the processing time that's available to you. So we'll look at time versus accuracy versus area. All the tools along the bottom of the screen will pick up point cloud, but what size area do you need to capture? If you're capturing whole cities, then the MX9 is going to be the tool for you. If you want to do a quick floor plan of a building, then actually perhaps the ZebRevo is the tool to use. And it all comes down to the deliverable as well. What actually you're looking to get out of the scan data. So specifically then looking at the SX10, well, what's the return? I mean, with the SX10, you actually get a 1 second robotic total station with a scanning capability up to 600 meters. So in its own right, that 600 meter range makes the SX10 a very, very capable instrument with very good, clear quality scan data. And what's key with the SX10, for me, is the ability to take one instrument into the field. It's only one instrument to store, it's only one instrument to insure, and one instrument to service. Whether it's a large company, or a single engineer on site, or a land surveyor going around the country, it makes life far, far easier only to take one box out of the car. So when we look at the traditional survey toolbox, this is primarily, I guess, what we now accept as being in there. And you've got your level, your robotic total station, your controller, and your GPS. And so, how do we make that next step? Especially when a lot of companies, the bread and butter, if you like, would be your total station. And so that's always the thing that kind of gets updated first. And so if you wanted to update your robot, but perhaps in the same year, you were looking to get into scanning, actually, if you were to do that and buy a traditional scanner, you're probably looking at about 75K. So it's a very big investment. But when we look at something like the SX10, it does make a lot of sense. When we look at the SX10, take away the 2 units and combine the 2, all of a sudden now we're down to approximately 45K. So investment, it really does pay to have a look at the options rather, and the type of jobs that you'd be carrying out with the equipment. So how do we take that leap into laser scanning? So Neil Main, he's the MD of PM Consultants. They're a well-respected multidiscipline practice. They've got 7 surveyors, and they're operating nationally. They've got a client base that most surveyors would be familiar with in architectural practices, property developers, and civil engineers. For them, it was about the right time. Until September last year, PM Consultants had steered clear of laser scanning and even turned down work requiring 3D point cloud deliverables. And this was due and large, to not having sufficient work to actually justify the outlay of a scanner. However, requests were still coming in, and by September last year, they're actually now tendering on large projects that did actually require the use of laser scanners. So this was the right job. So although still reservations, Neil decided to start researching into laser scanners and have a look at what was out there. And as a long-time Trimble user, it wasn't long before he happened across the SX10. So it was the combined functionality of this SX10 that stood out for Neil. The precision measurement and the robotic features, alongside the long-range, high-quality scanning and imaging. So could this be the right instrument? Such a versatile instrument could be used on a wide range of projects, whilst at the same time increasing the size of his robotic fleet. This made for a great investment for PM consultants. So as an example then, this is an old barn. Elevations, for these guys in city centre areas had for a long time been a no-go, purely because of time constraints and the amount of work they had on. With a traditional instrument, it would have taken too long. But this was an area that they were keen to really explore with the SX10, and a job would come up for floor plans, detailed elevations, and a topo. And a tricky one is it was an old barn, very lopsided, and was actually full of junk as well, so access was an issue. Now that scanner, they'd actually estimated that they'd probably take about 3 days on site, and due to requirements for other work, rather than a standard two-man team, actually sent a single guy out. But on his own, the guy was still able to complete the data collection in under 1 day. So they actually managed to save 2 days, which is a fantastic example of how the SX10 can work for a company. Now this was put down to the ease at which areas could be selected for scanning. Traditionally, scanning takes a kind of a scan-all approach. But with the SX10, as I mentioned earlier, it's very easy to select specific areas to scan from the live video feed. And this both speeds up collection and eases the processing. Often with scan data, you'll scan lots of points right near the scanner, which actually we just don't need. And so by specifying which areas you need, makes the software less clunky as well when you're downloading. So another example, this task was to carry out a topo survey of rails running under a road bridge in preparation for a replacement support column. The SX10 was utilised for its 1 second high accuracy capability to put in the control and conduct the topo survey. And the deliverable they were looking at was, it wasn't the one that's on the screen, but a pretty standard 2D line drawing. But after completing the topo, to add value, they also carried out a scan of the underside of the bridge to show positions of the steelwork and any of the planks. As a result, the client actually requested further scan data to be collected, and PM consultants were tasked again to go back to site and carry out more work and more scans. All the survey work was completed at night, with the ability to view all the scans as they went. It was also very easy for them to be 100% sure that they'd collected all of the data that they needed. And this is a great example of how surveyors are often the ones, we're educating the industry, on what's available and what can be achieved through data collection. By adding value on the initial task, they won further work. So what's the SX10 done for the PM consultant? Well, it's enabled them to offer a higher level of service, reduce time actually spent out on site, and gain more data in inaccessible areas. And not only have they been able to reduce the time on site, but they've also been able to reduce site visits. As often happens, you'll go out, you'll complete a survey to the brief as given by the architect, and then 2 weeks later they'll come back and say, "Oh, did you get that measurement? Or did you get this?" Well, in the past, that would have meant a revisit. Or had you collected your data up and processed it, and you got the underlying questions, would a site revisit be needed to do a further check? Whereas what a lot of companies and PM consultants included are doing now with the SX10 is every station setup, they're doing a quick 360 to enable them to take the site back with them. So any checks that need to be done, can be carried out in the comfort of the office. One of the biggest things that Neil Main cites the SX10 has done for them is offer peace of mind. And that's a huge thing whenever data is your deliverable. It's peace of mind that you have all of the data and you can check it and it's got the quality there. You've got that redundancy because you've picked it up. Perhaps when we're talking about a topo, you've picked it up with the Pogo, but also you've got that data there in the format of 3D point cloud as well. So how else are people using the SX10? So Storm Geomatics, they're specialists in water and rail-based projects. They have their own in-house GeoRiver software based in Gloucester and Bristol, again operating nationally. So these guys do an awful lot of water work, as I said, and they got hold of the SX10 for a specific job that they had, looking at this waterway. Now, Storm were tasked to measure this water, and they were not actually interested in the bridge, but it was the obstructions near the water that they were after. So using their tried and tested hydrographic equipment to measure below the waterline, the SX10 was then used to scan the scene above. So this data was later merged together in the office to give a full picture of the scene. And so we're able to merge point clouds from different sources, and that worked really well. And you can see here some of the pictures that are actually taken from the SX10. So not only do we have the scanning capability, but we also have the imagery to draw on as well. So I've taken the data actually into Trimble Business Centre. We can see here, this is kind of from a station view, and you can see the imagery that's been taken. But I can then overlay the point cloud data with that. So here we're looking at the colorized point cloud data, and you can see the path there, or the bridleway, and the vegetation around. Make it a bit easier to see. We can have a look at it in color-coded intensity. So this then really starts to bring out the detail, and we can still see the imagery in the background. You can see the clouds and the water running down the river. So it's a really nice viewpoint. I won't talk a lot about Trimble Business Centre, but one thing I will mention is the auto classification tool. So this is a nice tool, and it's not 100% proof, but it gives you a fantastic place to start from. So what you can see here now is the classified areas. So it's classified buildings and structures as blue. It's classified the track there, or ground, as brown, and it's picked out the vegetation as green. So straight away, when we come to clearing up projects, we can very easily start segmenting the data and taking out effectively the noise. If we think, for example, if you were in a high street area, lots of cars moving through, lots of people moving about, what this will actually do is segment out and classify a remaining area as well. So, excuse me, data that doesn't kind of fit into the ground, into the building, the vegetation, poles. So it classifies as remaining. And what that'll do is it'll take out, the people, it'll take out the moving cars. And so straight away, it's a lot quicker to process the data and get it into a usable format. So this is quite an interesting one, a measured response in a crisis situation. So Thai Cave rescue, everyone is no doubt aware of the amazing rescue that took place to save the World War football team from being trapped in the caves. A truly fantastic result to get all the boys out safely. Perhaps less well known, thankfully, as it wasn't required, was Plan B. So if the water level had prohibited the rescue mission and they were unable to use the tunnel they found, as a backup strategy, the Trimble SX10 were actually used to scan the terrain and elevations inside the caves to provide interactive mapping in case they needed to drill down from the top of the hill to reach the boys, I guess in the same way they did over in Mexico in the mines, I believe it was. Thankfully, they didn't need to do this and all were rescued and reunited with their families. But you can see here it getting lugged through the jungle. I'm pretty sure that guy would be pretty disappointed to learn that there was actually backpack straps on the side of that box and he didn't have to lug it through like that. But yeah, you can see the equipment getting lowered down, and the tripod following it down into the ravine there. I'll just go to the next slide. We can actually see the guys surveying with the SX10 in what must have been pretty horrific conditions. But yeah, a very interesting job for the SX10 to be involved in. So back to the UK shores, and let's have a look at deformation monitoring. So Greenhatch, a huge company, over 30 years experience, carry out all forms of geospatial surveys, employing over 100 staff and regional offices covering the UK. So in a project in London, the forces of nature in the shape of the tidal River Thames meant a limited period of access for Greenhatch surveyors, providing just the sort of challenging site conditions ideal for the multifunctional SX10. A routine laser scan on a building alongside the river found brickwork on an abutting property that was bowing, which led to a monitoring project annually over a 5-year period. Now, monitoring by total station was initially ruled out because there was as yet no indication of where to put the targets. All we had was proof that there was bowing. So the Greenhatch engineering manager, Jordan Knight, suggested 3D laser scanning is the best method, with the initial scan used as the base data. So work had to be carried out from the river's beach, which presented new challenges. Access was by slippery steps, and scan time on the beach was restricted by the tide. So using the SX10, Jordan was able to establish an external control from outside the zone of influence, so that each time he returns to the site, he can go directly to it, saving time as well as giving better accuracy and repeatability. Employing the SX10 for this task also halves the amount of kit that was needed on site. Very important when you are restricted in such environments. So laser scanners often capture significantly more data than is actually needed. And so Jordan was able to select the data required to match the speed of the process that was needed. So you could draw a polygon very simply using the tablet, live video stream, and you could define the area and scan density. The tablet also gave him a clear visual of the scans captured, so he didn't need to go back to the office to register and check that he had everything. Whilst on the beach, he was able to spot immediately that on the east side of the building, more data was required due to an overhanging balcony obscuring the brickwork behind it. So in the future, thanks to the long range 600 meters of the SX10, Jordan will be able to access the job, site access permitting, from the other side of the river also. So back at the office, it was all registered. Well, it was already registered. It was processed. We can carry out a least squares adjustment, and that will actually process the scan data as well. And then deliverables were created in TBC. Well, record attempts. So another fun one. Apparently there was a big wedding early in the year. So a world record attempt by a Windsor-based organisation called Busy Buttons. So this is a non-for-profit community interest company. They do a lot of work with children and disabled. And the aim of the project was to commemorate this special event by bringing together around 2,000 participants representing a cross-section of society to make a truly memorable and community-spirited event. So the idea was to create the world's longest concertina card, individually signed cards from the local children and all stuck together. The final card was around 1.3 kilometers long, and the distance measured by the SX10. So that was a great one to get involved with. That was my colleague Chris Harris having a nice day out in London. And this was to be given this card was to be given to the royal couple as a wedding gift. So I'm not sure where that one will end up. So now's the interesting bit. We'll have a look at a live demonstration, all being well. I'll link now to the SX10 and we'll have a play. as if by magic. Okay, so those that haven't seen it yet, this is the new Trimble Access, so the updated version. Now, the reason for this update, primarily Trimble are now making use of the bigger screens that are available to us. The release of the TSC7 and prior to that, the T10. The old Access was designed for small screens and big thumbs. We're now making use of the much larger screens available to us. So first of all, you can see my project here, RV Cornwall. Yeah, I'm sat down in the sunny southwest, and I've got a job there called Day One. So first thing I want to do is set up my instrument. So I'm going to go into Measure, and exactly the same as before, it gives us the options to what you want to connect to. So I could use this, connect to my R10, connect to the SX10, any standard S series. We're going to connect to the SX10, and then it's going to ask me, exactly as it did before, how I want to carry out my station setup. So for this, we're going to do a resection. Now notice straight away it comes up, and the first thing we see is our optical camera. So that looks straight down, and had I set up over a point, you'd see a nice little nail there, and you'd be able to see how well I'd set it up. So considering I'm now sat in my conservatory and the instrument's sat outside, we're going to call that, it's green, it's good enough for me. So we'll accept that, comes up with our corrections, so we'll leave it at 25 degrees, and we can move on to our instrument. So straight away then, we can now see straight through the lens of the instrument. I don't need to be stood behind it, so we can start with our resection. So first thing I'm going to do is give my station a name, so I'm going to call it station 10. I can call it a station. Leave the height at 1.5, and we're just going to accept that. And so now it's going to ask me for my resection point. So I'll call it point 2. Now I could, if I wanted to, just drag it down from a list, and we'd see all the points that I've actually previously measured here. So point 2. And then I'm just going to point to my target. So anywhere on here that I point with the instrument, I can actually direct it to where I'm going. And then I've got the plus and minus button here where I can zoom in and out. Now you'll see a ladder here. As I press the plus, it'll go up through the camera zoom levels. And you can see here it says overview. 5 cameras on the instrument. Camera 1 being the optical camera, camera 2 being the overview camera. If I look there, we can actually see target locked. Target locked. It's still the same woman. You can turn her off. If I zoom in a little bit further, you can actually see my prism just at the top of the slide there. So I can take a measurement on that.
Observation stored.
Happy days, that worked nice and easy. Now I don't need to necessarily point around the scan data in order to move the instrument. I've got these buttons down here that actually allow me to move 180 degrees, or actually 90 degrees at a time. So I can click up here. I've got my other prism there somewhere, so I'll just click there.
Target locked.
Target locked. So I can now sight on to target 3. Hopefully that's the right one, and I can press measure.
Observation stored.
And there we go, that's my resection complete. So if I go to my results, so I look, happy with those errors. So I can store that.
Station setup completed.
Exactly the same as before. And now it throws us straight into the map data so we can see anything that we have here. So if I had any setting out data, DXFs, or any background images, I could load that up and I'd be able to see that on the map screen. Nice and simple. So now if I press the 3 bars up here, I can now go down into measure, and perhaps very similar if you're used to using the S series and Access, very similar screen, predominantly the same options as you get with the other instruments. With the S7, you still get scanning, you still get panorama. Obviously, this is set out slightly differently once you go into the tools. So into Measure Topo, I've got the option here of looking at my map screen so I can see what I'm picking up, or I can click here again and again, I can view my video feed. So from the comfort of my chair, I can now stick in my point coding. I can then go to my codes, store it as a level. And then I can start picking up points. So you can see there, I'm going to have a barbecue and a can of Magners once I've finished this. So if I want to start measuring, I can click on the instrument icon, go into DR, and I might also put it into tracking as well. So we're constantly taking measurements there. So it's just a case
stored.
Of storing.
Observation stored.
Perhaps I want to pick up the line work here of this of the patio. So I might, for lack of another code, I'm just going to call it a fence.
Observation stored.
And I'm just going to go through.
Observation stored.
Some points there. Ooh.
Observation
and
stored.
notice straight away on the live video feed, I can actually see my line work as I'm drawing it in. So I spoke a bit about the overview camera. If I just go back down here again, you can see the zoom level. So we're into the overview camera now. I can now go through into primary. Level 4, level 5. Now this level 5 is probably, turn off DR. Level 5, I guess, is akin to if you're actually sighting through an instrument itself. So that's kind of the level zoom you'd expect. If I go a lot further, you can actually zoom in. It gives you a very clear picture. Unfortunately, my garden is, well, unfortunately, depending which way you look at it, my garden is very private. So I can't actually see a great deal to get any range. But if I wanted to, I could just double check on the ingredients in my can of cider later. So as you can see, the camera itself is giving us very clear imagery. So, and this is the key thing when we're talking about the SX10. It is a very good robotic instrument in its own right. I could have got one of my kids to hang around, and I could have actually got them wandering around with the pole, but they would have been too much of a distraction, so I sent them all out. But if you want to take a greater look, we can come out and it can show you it working, tracking the pole with absolutely no issues whatsoever. And that brings us on to the fifth camera. So the fifth camera is actually built into the instrument and is actually used for tracking. So unlike the S series or the standard S series that has active tracking with the diodes, this actually has an active camera tracking system. So it's using the camera technology of the instrument to help track the target itself. So as well as using the instrument for survey, we can absolutely also use it for setting out. So whether I click onto the map, I can then review points, or I can actually stake out those points as well. So it's a very functional, capable machine. So just to get that out of the way, just to dispel, just to prove the point that this machine does all. What we'll now do is we'll actually have a look at the scanning element. So into the scanning screen, and what we can now do is I can actually choose what I want to scan. So as I move around the screen, it might be that I want to have a look at exactly what's going on. What I'm going to do is just go in here and escape that. There we go. So from here, I can have a look around the scene. I can actually now select what data I want to scan. Now it might be that I'm going to fit a hot tub for Mrs. Bowles in the area here. Bit of an upgrade from the swimming pool, you can see. And so what I want to do maybe is actually get a bit of a scan of the area, see what the levels are like. So how do we frame it? Well, we can do, if you want to do a full dome scan, that'll take 11-12 minutes. And that will basically give us 10 mil at 10 meters. Okay. One of the key things here is the ability to actually really speed up the scanning through selecting specifically what data you want. Now, one way of doing that is a horizontal band. And what that allows us to do is actually select the top area of the data that we want, and then also select the bottom area. If all this is up here with sky, and this is just a few meters in front of you, do you need all that data? Well, possibly not. So this allows us to, again, really cut down the time, and that's almost cut the time by 2/3. So that's one way of selecting what area you want to use. Another very simple way is by selecting a rectangle, just by clicking 2 points, and then that will give us the area that we're actually going to scan. Now, the most commonly used method, I guess, is probably the polygon, and that allows us just to select user-defined area very easily by selecting points on the ground. And the nice feature about this is if I then put a point in that's wrong, I don't have to delete and start again. I can just press my back arrow and it gets rid of any previous point. So it's nice to see that they thought about that. So once we selected the area we're going to actually scan, we then select the density. So at the minute it's set to coarse, we can set it to standard, fine, and super fine. Now the scanner will always scan at the same rate. What this does when you go up through the options is it'll actually do more rotations. Now this is great because if you just slow down your scanner and do one pass, if you're in a busy area, you'll have lots of people moving around and you'll have shadowing. Whereas if you do multiple rotations, what that allows you to do is, okay, you might miss it the first time around, but the second, third, fourth time around, you have a chance of hitting it. So you'll get more noise perhaps in front of the area of interest, but you actually gather more data behind it. So it works really nicely. So once we're happy, we're going to just do a quick coarse scan there. I can also then select whether or not I'm going to take photos. So if I select on my panorama option there, we've got the overview camera and we have the primary camera. So the overview camera, much bigger images, very much quicker, but gives you kind of less quality as it were. Whereas if I zoom in and take the overview images, you can see it'll take a lot more images, but you can zoom in a lot further. It gives you a lot more pixels per square inch, gives you a lot more ability to actually use those images. So I'm not actually going to take any images now because we don't need to. So what I'm going to do is actually start the scan, and off we go. So while that's scanning, I'll just talk a little bit about how it's working. So there is a proper scanning element, as it were, inside the instrument, and that's rotating vertically. But then also there's a prism that's rotating horizontally. And what this is doing is it's actually splitting the laser 16 times. So rather than in kind of a traditional instrument or scanner where it's just one laser flying out, it's actually got 16. So it is literally scanning in bands. And that's what helps it give it the speed. You'll notice in the bottom right hand corner there is a pause function. So at any stage if a big red bus parks in front of you, you can actually pause the scan and then carry on once the area is clear again. Also, a very nice feature is, should the battery run out, you can also put in a new battery. It'll ask you to level the instrument again or check the level.
Scan complete.
And then you can carry on from where it left off. So you can literally run the batteries on this down to the ground before you have to swap out. So that's a really nice feature. Now at the minute I'm actually cabled to the instrument because my Wi-Fi is logged on to the internet. But generally we'd use Wi-Fi to connect to it. There is also a long-range radio, and we use this generally for when we're in topo mode. We use the Wi-Fi because of the amount of data that we're moving to and from the instrument with point clouds and imagery. But again, if you lose Wi-Fi link, it'll actually buffer all the data on the instrument, and so when Wi-Fi is regained, it'll then send all of the data across. And this is great because it allows us to set the unit off scanning, and then we can connect the GPS, and we can go off and we can collect data with the GPS whilst the instrument's scanning. So we're not stood waiting around for the scan data to be gathered. So straight away here, you can see the scan data through the live video screen. And if I zoom in, we can have a look, and you can see where my grass is sadly dying. That's probably a prime spot to put the hot tub. And if we click on the video, the map view, we can actually then as well zoom in and take a look at see the data. So I can actually view that and look at it in 3D as well. So we can't see a lot, other than perhaps that I've got a bit of noise there. I think maybe it's time there's a few bits of grass cutting required. So what we can also do is turn on and off individual scans. So if I go into my scan option here, we can see another scan that I prepared earlier. I wasn't going to make you guys watch it for 5 minutes. So I accept that, and then straight away we can see the rest of the scan data. So I did a quick band scan here of my back garden. I just move that around. So you really get an idea of the data that you're able to capture. So this was just a 5-minute course scan. You can see how it's picked out the brickwork, satellite dish. So you really can have a quick look around and make sure that you've got all the data that you needed to gather. So if I just turn that off again, as mentioned earlier, one of the things we can do is use it to check levels. So just to make it a little bit easier to see, I'm just going to turn off that original scan and go back to our little face here. So as I just zoom into that, one of the things I can do, let's pan that across, as I can actually, with my target, I can actually select any individual point of the scan. And I can actually review that point. As I review it, it calls it a scan 001 point, and it actually stores that in the job. So I can take that back, and I can see the elevation, see everything that's going on with that point. What I can also do, rather than just selecting a single point, is I can select an entire area. So if I want to see what's going on with this area here, I can select it all. Again, if I hold down, I can then create a surface or computer volume. So if I create a surface, call it S1. And then straight away, we get a surface created. If I just turn off my point cloud. So you can see the point cloud, and you can see the differences in elevation. So straight away, if that was a concrete pad, we'd have a fantastic idea of exactly where any high or low spots were. So very good for very quick checks in the field. And one thing I didn't show you, going back, if I turn them all on again, is we can go back into the video feed. So as well as being able to see all of the data, turn it on. As well as being able to see all of the data that has been collected. Hang on, what's going on here? Just escape out of that. There we go. Just going to go into video view. So what we should be able to see now, he says, live demos over the internet. Boom. So what I will show you is all the scan data in a single setup. I'm just going to restart my Access software. There's no kids involved, but internet is normally a good one to not work with.
Connecting to SX10.
I would make the excuse that I'm down in Cornwall and our internet is not the best, but here we go. So we're just going to connect straight back up to the SX10 again, and we shall have another look. There we go, internet SX10's connected back up, and what we should be able to see is our scan data. So it appears that I have actually broken access. We'll see if that comes up in a minute. Let me just try a different view. There we go. So from this perspective, it's very clear and easy then to see. You can see where the bottom of the banding was. Gives you a really good idea to the data that actually been collected. So that is probably about it for the demonstration of the SX10 itself. And just to prove that it's live, I'm joking, second me. We can see, not only can we see the data, we can also see ourselves working. So we'll flip back to the presentation now. There it is. The SX10 is a fantastic unit for beginning or advancing your scanning journey. Multiple capabilities, whether we're talking scanning, high accuracy surveying, all for less than £35 a day. Get in touch. We've got a great interest-free finance deal running at the minute. So what I'll do is first I'll say join the conversation. We're all over social media. Join us on Facebook, LinkedIn, Twitter. But if anyone's got any questions, I'll be happy to answer them. So let's have a look, see what's come up. Let's have a look. With the recent spate of thefts, does the SX10 have security immobilizer and tracker, as it's a big investment? Good question. With the SX10 itself, it doesn't actually have locate to protect fitted into the instrument itself like the standard S series does. This goes to show how long this unit was in the making. Trimble don't just pull these things out of the back pocket. When the SX10 started off life, this was prior to L2P. What we do offer is the option to actually fit it into the box. And so in the event that it's stolen whilst in this box, we can still track these and return them to their rightful owners. Paul Williams preferred me with the mask on. Thanks, Paul. What software do I need to process the data? So we've got lots of options. Well, lots of options. We've got a few options with regards to processing the data. We can either bring it into Trimble Business Centre. A lot of our customers already are using Trimble Business Centre, and then you can just get hold of the scanning module, and that'll do the processing that you need. And the other option is Trimble RealWorks, which is Trimble's kind of bespoke point cloud solution. Now, RealWorks has been around for a long time, and we've used it, from the old GLS scanners, TX scanners, and it is a great tool. And really, for me, it depends what you're going to do with the point cloud data as to what software you need or require. If you're already heavily into laser scanning, then you already have some kind of point cloud data tool. And so, actually, to really make the most of the investment, then Trimble Business Centre is the way to go. If this is a first inroad into laser scanning, and it's the 3D cloud deliverables that you're looking for in analysis, then you'll get more of that from RealWorks. But really, it's kind of on a case-by-case basis, depending on what workload you're looking at. How does the scan quality compare to a full scanner? Well, the scanner itself, the scan quality itself, is fantastic. It's a 1 second robotic instrument, so it is high quality. It's very clean data. And what's really nice about it, what adds to the cleanliness and the quality of this data, is the ability to actually robustly control the data. So we can do a high accuracy traverse whilst scanning around. So that error that's that you're putting in through having targets close to the scanner, or having to use other means of controlling it, that's kind of taken away. So we can very much use traditional survey methods, which was one thing that certainly when scanning first became an option open to surveyors, a lot of surveyors kind of looked at it and said, well, how's that controlled, and how do you keep the accuracy? So that's one of the concerns now that the SX10 kind of answers. Going on from that, moving forward from that, if you then take the data into Trimble Business Centre, you can then calculate any adjustments that need doing with the traverse, and that'll actually play out into the scan data as well. We want to know how we can take the top of buildings scan if we can't reach it. So I guess one of the benefits of using scanning in general is the fact that you don't need to be able to look for, you don't have an eyepiece to look for it, and that's the same with the SX10. So I guess one of the things we can do is put it on an elevated tripod, rise it up, and take the scan from there, which would give you far more information. Failing that, a lot of people nowadays, there's also the option of UAVs. This is not a one-stop solution. There's lots of different ways to skin a cat. Can the scans be used to calculate volumes on site of muck in access? Yes, absolutely. So there is options to, once you've created a surface, you can then, if you've got two surfaces, perhaps you've got a muck heap, and you want to know how much has been taken out, you can, in Access, you can compare the two surfaces that you've created. You can also calculate a spoil heap, assuming a flat surface, or creating a level or a surface from a line around the bottom. So yeah, absolutely, you can calculate volumes, and that's one of the really nice things you can do from the scan data. If you wanted to, you could even scan one side of it, run around the GPS around the other side, and do it that way. Particularly if there's a face that's being worked. So it's a nice way of working. Any other questions? Okay, well, look, I hope everyone found that informative. Appreciate you guys all coming on board. Please, this isn't the it's the end of the presentation, but it's certainly not the end of the quest for the SX10. So if anyone's got any questions at all, thinks of anything in the future, please contact myself or any of the guys at Coret Group, and we'd be happy to come along, answer any questions, perhaps give you a real-time demo, and so you can get your hands on the kit and take a look. It's very worthwhile doing. So thank you very much, and I'll see you again.